So, hi everyone, welcome to this call. We're very excited to have you here. The goal of this 101 submission is to be able, first of all, to talk about the challenge, answer any of your questions, and also guide you through what a submission looks like end to end. And so, just to get started, we gathered a little guide with like some resources for participants. I will share the link in the chat and then it will be uploaded on the website. But basically here you have anything you need to get started. We can go over it after. And so it starts by sending you to the competition website. So this is the IOL-AI 2026 challenge. I think you're all familiar with this website if you joined, but just like a little introduction. The main question here is, can a system reason out a language it has never seen? And it makes LLMs take the IOL 2026 exam. So the exact same test the human participants will sit. And so just a quick note on why we are so interested in these problems, the International Olympiad Linguistics problem. It's because they cannot be solved from memorized facts. Each one is built on a language you or the model probably has never seen, so it really challenges the reasoning. And so the task is that you have to answer these questions. So here are a few examples of the type of tasks your model could encounter. Here you can see a translation task, and you see that these models are self-contained. So everything you need to solve the question, the query here, is in the context. So it gives the context. It asks you to translate, for example, this word into English, and then the model or the student produces the answer. Here's another example of number transliteration. And so how do we score you? We use two metrics, the exact match metric, which we check did the model answer exactly right. So it's either 0 or 1, and then a CHRF metric where you can get partial points on the n-graph overlap, and then your final score is the geometric mean of your exact match and CHRF score on all the questions. Now the data, you cannot unfortunately see what your model is trying to solve because this challenge is not out yet. The students didn't take it yet. So you cannot see exactly the questions that your model is trying to solve, but you can get an idea at like what the test set looks like. So here's exactly how it looks, every field that you can see. So you can see you have the context here, and then the query, and then the type of task. So if it's translation, fill in blanks, if we're asking it to match letters, and then a type of evaluation, like is there only a single answer that is true or are there several ones? Also, a quick word on the human evaluation challenge that I'm very excited about, and on our current submissions didn't take a look at it yet, so we don't have any participant yet eligible for the human evaluation challenge, but it shouldn't take you too much time, and it's very interesting. So since we're collaborating with IOL, we will have human judges evaluating the best submissions, and to be eligible to that, you just have to add an explanation field in your submission to basically summarize or walk us through how your model thought or reasoned or solved this challenge. And so if you fill this field, you will be, and you score well, you will be eligible to that, and you can have real judges evaluating your submissions. This is quite cool. Now moving on to the most interesting part, the submission one. So how do we actually make a submission? Just to make it clear, you are not submitting a file, you are submitting a public Hugging Face model repo. And it's worth knowing that the eval sandbox has no internet, so you have to ship the model's weights, only use open models first, and you have to ship the model's weights and your script and everything you need inside that repo. If you try to pip install anything or access internet, your submission will fail, unfortunately. So just make sure all of this is done. And so inside that repo, you need to include a script that will read the test set, and you need to have the script write a submission CSV with 1 row per problem. And then you can just enter your model repo into the competition space, and we grade your submission. But I'll walk you through that step by step. So here's an example of a script that we wrote. This is just like a skeleton of what a script looks like. It's the minimal one, and you have more details about how to make a submission here on the competition space. So this basically has the same information as on the website, but if you go to submission information, you get a very detailed walkthrough at how you make a submission, what needs to be inside of your script. And yeah, if anything is not clear and you have read that, we can like feel free to ask any question. And so this explains to you how you create a model repo on Hugging Face. So to create my own model repos, I use exactly this. You just you run it on your own machine. So I do it on Google Colab and it works very well. You just have to authenticate into Hugging Face. And so you you change here your username, your submission, and make sure to change here to the right model that you want to use. So here, just an example. And then, so this puts the model weights in the repo so the offline sandbox can load them. And then it adds your script to the model, but I'll show you what it looks like when I did it. And this is the same example of the script that you saw on the website. I'll show you an example of a script that I wrote. So I used this template and then changed it a little bit, adapted it. But just a quick look at here, the system prompt, you can see it's very minimal. It just gives a bit of context, like you solve international linguistics Olympiad problems, and it asks for the answer right away. So answer every numbered item, and then it tells the model to put each answer on its own line in order with no numbering, so it's easy for parsing. But to show you what it looks like, so I ran that exact code on Google Colab using Quen 2.5 14B AWT. So it's a 14 billion parameters model, and it created this Hugging Face repo where you can see we have the model's weight and we have my script. If you want to modify your script, you can do it from here on the platform directly. And so this is a look at the script I wrote for my model. So the main thing that I changed, the structure is the same. And then the main things that I changed, for example, here, the number of tokens. On the other script, it was way lower, but for this model, I increased it. And I encourage you to maybe play with the number of tokens. The higher you put, the more room for the model to reason, but the lower, then the faster. And if sometimes your submission is over time because you have a 30 minutes limit for your submission to run, then it might be worth trying to lower it or increase it if the quality of the chain of thought of your model or answer is not what you wanted to have. And this is the most interesting part for me, which is the system prompt. I really, really encourage you to like use your creativity and try to iterate on this because we saw, and maybe Julia will say a word about it later, then even with a small model, if you have a good system prompt, then it can even exceed the score of big models. So you can see mine is a bit longer than the one we had on the website. So I still give the context, but giving like some details about the type of tasks that the model can encounter, because we know and we saw it on the data set that in the test set, it indicates the type of task that the model is currently solving. So I gave a little instructions at how I wanted the model to approach the task depending on its type. So you can see here that I'm saying that the model can meet a type of task that is not listed here, and that if it's the case, then it should adapt to what the instructions are saying. But if it encounters one of these common task types that we usually see in IOL, then I give some instructions at how it should solve it. And another main difference is that I ask the model to reason step by step first, then write a line that says exactly final answer, and below it, one answer per line in the order the items are asked, like exactly how the other script was saying. So I think allowing your model to, this is not a reasoning model that I'm using, but allowing the model to show you its chain of thought and like show you how it's thinking about the problems, might increase its performance. But just a disclaimer that you need to be able to parse the answers, which was not the case in the other script because we just asked for the answers right away. So here I added a parse function that detects this final answer and then disregards everything that was before it, so the thinking, and keeps only the answer. And then the rest of the script is basically the same as what you saw on the website. Yeah, so this is my script. And then maybe now I can show you how I would do if I wanted to submit it. If you have any question, you can just raise your hand and Julia will tell me. Yeah, so now this is my model. Make sure it's set to public, otherwise it won't work. You can copy it here and then go to the Hugging Face platform, and then you can click on, make sure you're authenticated. Being authenticated only on like Hugging Face here is not enough. You need to make sure that you logged in here. So yeah, now I'm logged in. I'm gonna go to new submission and then just paste this here and submit. It's going to take a bit of time to run, but yeah, success. You have 4 submissions remaining today. We increased the number of submission per day to 8. I already did 4 today, to allow you to iterate a little bit. And so if I want to see my submission, I can just go to my submission here. I can see the name of my team. Feel free to change that. So it's baseline Quen, and we'll see it appear on the leaderboard. And so you can see this is my most recent submission. It's currently queued, and you'll see the status update itself. So either failed or processing, or you'll see the score appear. So it's going to take a little bit of time to update. And in the meantime, maybe we can take a look at what the leaderboard looks like for now. So we have some participants. You can see this is the exact model I just submitted. I did it earlier, so you could see it on the leaderboard. But for now, it's first. So you can see the score and then the CHRF and exact match. The explanation rate here is 0. So that's the field I was talking to you about, that you need to add to your script if you want to be eligible to the human evaluation challenge. So you saw in my script, I didn't include anything on the explanation, but I'll show you on the Google Colab later how you can do it. And then you can see our other participants, and then we have a baseline of Tiny Aya that Julia submitted earlier that maybe she'll explain to you later. Do we have any questions yet? Or
yeah, we had a question from Muhammad, who was asking if we get feedback on the model submission.
For now, the only thing that you can see is the status. So you only see if to what stage your submission is, if it's queued, or if it's processing, or if it failed or succeeded. But we are thinking about adding more details on the submission status, and especially if it fails, giving you some information as to why, so you can iterate on it. So we increased the number of submissions you can make a day, so you have more tries, and we're thinking about adding the reason why your submission failed, so that you can have even more insights.
Yeah, and you never get to see the inputs or the outputs of your model. And this is because, so it's like a double blind task, because these tasks are truly unseen. They're going to be used in the human IOL competition, so we can't disclose them to anyone. So you have to work with the knowledge about what your model is scoring. But Rita will also show you what you can use in the meantime, because we understand this is a little tricky. And so there's a benchmark that you can use for kind of like development, and kind of also kind of figuring that you can make the setup extremely similar to what the like the Hugging Face space environment looks like, so that you can catch on kind of errors, you can inspect typical outputs, you can improve your parsing. So there's a way to do proper development with a little more information. Just for these tasks, for these specific tasks, you won't be able to see them. Your model will run on them, but we won't give you outputs on what we won't give you the actual strings that it output.
I think there was a question about trying to load the chat.
Yeah, about open weights, whether we can use very large models.
So your model is running on the T4 GPU, which allows only 15 gigabytes or approximately 16 gigabytes of storage. So since you need to load all the weights of your model, this gives you a limitation of how big a model you can use. So the model I just showed you is a 14 billion parameters model. And we were able to use that only because we used a quantized version of it. So if you want to try using a big model, use a quantized version of that one. And the one I've been using is the biggest one we've got so far. So you can try and experiment if you want with the bigger one, but I'm not sure it will run. If you run into a submission that is failing, it probably because it didn't have time to load everything while respecting the 30 minutes like deadline, and also the T4 on like putting everything on the T4 GPU.
Yeah, to add to that, why we're doing that. So in past evaluations, it's always been shown that large models do have an advantage, and partially because they just memorize much more as well. So maybe they might have seen some, I don't know, grammar example on Wikipedia in pre-training, even for very large, rare languages. And so they might be able to memorize much more of this. And so so there's a very clear big difference between especially closed models and open models. And then within the open models, there's so far in the literature a very clear kind of decline that small models basically don't have a chance. And that's something we want to challenge here, because we want to isolate the reasoning capabilities. So it's also kind of an open and resourcefulness challenge here. Can we get small open models, smallish open models to compete, be like really like get better at this, where your advantage is not parameter scale, but like clever use of parameters. So you can imagine you have a lot of room for like prompt tuning, you can do iterations. Imagine you have half hour, you can call a small model many times. The test set is not that large. I don't think we can disclose the size, but it's small. If you look at the typical IOL problems, you can look at them from the last years. They're in the resources, they're linked there. It's not a lot of problems. So you can think about how you can use that compute the most optimal way to kind of unlock the best possible answers for those.
Yeah. There's a question about the evaluation scoring metric. As we cannot foresee this year's problem in advance, what if the answer involves drawing some unstructured graphical output? I don't know if we can disregard, like if we cannot give you much information about like what the test set looks like, but you will not be facing anything that we are not able to score, and anything that like a small open model cannot do. So for example, in the IOL, sometimes you have images or graphs, and so these are we make sure like before putting them in the test set, they are like we don't give images or graphs, we put them in a JSON format, so your model is able to read from them, and there's no difference between a model that could like understand this graph or a model that can't, so that it's fair. So this will not be a problem for the scoring, don't worry.
Yeah, so how this worked, like the IOL organizers, they actually were responsible for turning these questions into a machine readable format concerning the questions and the answers. So all the answers, the gold answers are in a list of strings. And yeah, these might involve some special symbols if the task introduces them. So in the past, maybe you've seen, for example, there was a task where you have to classify into whether this word is describing a woman or a man or some neutral, and then they would give you three kind of symbols to use for that, and then the gold answer would be a list of these symbols for each example. example, but it would be specified in the task. So there's nothing that, you know, would be a surprise or wouldn't be contained in the prompts as you get them. So you can use text-only models, and you will be operating on strings, and your answer will always be a list of strings, but it's also very clearly specified in the examples. So take a look at those, and then you know what kind of to expect.
I'm not sure, Julia, I understood your question. Like, what do you mean by the team problem? Maybe Julia, if you got that.
I'm not sure. So as far as I know, from the IOL, there's only one set of problems. Maybe for the regional ones, there's more.
I got it. The IOL has like a team, like you have some problems that you need to solve. Okay, I understood your question.
Okay.
The IOL has some problems that you need to solve by teams and some problems that you need to solve individually. Yeah, IOL has 2 rounds. Yeah, it's only individual problems. So it's not like the team problems. You're only sitting the individual round. Great. Can we also use some form of RAG if we adapt it to fit completely offline and local within our HF submission repo? Yeah, we haven't tried that yet, but I'm pretty sure if it fits in your Hugging Face repo, it could work. So experiment, as Julia said. I think it might be a good idea. So yeah, it should work. There's nothing against it. So as Julia said, we know it might be a bit hard to visualize what these problems look like, especially since we cannot like show you what your model is currently solving. The test set is hidden. So we tried to make it easier for you by creating a Google Colab where you can test your script on Linguini problems. So Linguini problems are the exact same format as the problems your model is encountering in the challenge, and this allows you to see what the chain of thought will look like, how your script does, what you want to change or not, and like iterate before making a submission. So this tool is in the guide here that I will share the link, and it will be on the website. So you can just click here. It will redirect you to a public Hugging Face repo, and then you can just click on the Open in Collab here. And it takes you to a Google Colab where you can test your IOL-AI 2026 script. So just make sure what is cool with Google Colab is that you can use a T4 GPU, and so get also an idea at how your model does on the GPU of the actual competition. So just make sure to click Connect T4 before running the Google Colab. So you can see here it's connecting. Yay. Okay, so this cell is just to set everything up. And since here I'm using a quantized model, I'm gonna run it. But if it's not your case, then you can disregard it. It's gonna take a little bit of time to run, but it's okay. Yeah, so the benefit of using a quantized model is that you can use a much bigger model while still fitting into the restriction of a T4 GPU. And so as you can see, as you saw on the platform, maybe we can take a look at the leaderboard again to see where my submission is right now. So you can see my submission is processing, so it means it didn't fail. And right now we're comparing my answers to the gold answers, and soon we'll get a score. But yeah, as you can see on the leaderboard here, my baseline on Quen is the first one. So this would have not been possible without using a quantized model, and our sandbox allows you to do that. So don't hesitate to do so. Yeah, so it's just charging and everything. And so after that, we're just going to load the test problems. Here, we are using Linguini problems. So what you do on an actual submission is you do df equal read CSV, and then you read the test set. But what we do here is that we load the Linguini problems. Here, I decided to load only four for the sake of this workshop. But you can load as many as you want. You can just disregard this warning here. It's okay. The session is restarting just to make sure I have enough storage on my T4 GPU. So let's load the test set. And then we can just load my script. Sorry, we can just load my model. So here in this cell, what we're doing is that we're loading my model. So you can see the model ID. It's the exact one as the one I showed you earlier, the same number of tokens. So this is to be as close as possible to what a real submission looks like. This is a tool to prepare you for a submission. So you have also a lot of comments to guide you through what you would need to change if you wanted to actually submit what you've been writing here. So it's very detailed, but it's for you to be able to just take what you've been doing here as a practice and then put it in a submission. And since it's running on the T4 GPU, which are the same as the one on the Hugging Face platform, it gives you an idea of how long does it take for the model to load. And this time is a part of like your 30 minutes limit. So if it's taking very, very long here, then that should give you an insight at how long it will take during the actual submission. If you have any question in the meantime while my model is downloading, feel free to ask. Maybe we can take a look at my system prompt. So it's the same one as the one I showed you on the script. But yeah, so you have several parameters that you can play with. So the system prompt, the number of tokens, the parsing and the parsing function. Keep in mind, like this should go with how you prompt your system. So if you ask something different here, then make sure to fix the parsing. Otherwise, you could lose points on, for example, your answer is not being parsed very well and not being aligned with the right, like not being compared to the right code answers. And this is great because since we're going to test this on Linguini problems, then you're going to see if your parsing function works or not, and make sure you avoid any mistake on parsing or comparing to the right gold answers, so you don't lose points for that. So your parser must match the format of your system prompt.
So we had a question about packages. Yes, packages have to be delivered within the repo, so you can include wheels for that. Whatever you would usually install with pip, you basically have to ship it. I encountered this when I was building this tiny Aya baseline where to cohere architecture needs a different transformer version, and then you basically need to deliver that. So in your script has all the things that it specifies all the things that need to be uploaded in the create submission script. Basically will like it will have all the pieces that will have to be copied in your repo and in your script. And so you can also include any kind of code, local dependencies in there that then your script will load. So it's a bit more of a workaround, but you can definitely make it work. I recommend the help of coding agents for these kind of Python dependencies because they can be less fun to manage. But yeah, you can also, if you have questions about what's in the sandbox and you know, like versions, let us know. Hopefully we will be able to expose some of the logs as well. Just need to make sure that we're not exposing anything that's not to be seen. And yes, you can reach out to us, not necessarily about feedback for your submission, because you know, we also don't know what a really good submission looks like. You know, we're learning as you are. We're hosting a competition to actually push and advance the state of the art. So our hope is that you all explore different ideas and, you know, come up with creative solutions. So, you know, the ground truth is the score. So the score will be more helpful than our feedback, ideally. When it's about technical things, yes. And we have a Google Groups mailing list that you can contact. I think it's, yeah.
I can for the Google group. So it's here and in every other page. So you can just click here and then you reach a Google group and then you start a conversation and you can reach out to us. And you'll always find a member of the organizing team online to help you. Especially if you have like a technical problem, like Julia said, we cannot give you some guidance on how you could improve your system prompt and that, but we can give you some guidance on like what are the dependencies, what's working or not, and if your submission is failing and you don't know why, we can help you through that.
There's also this community discussion option on Hugging Face Spaces. So we had one person already raising a question there, and that's very helpful because then everyone can easily see it. So if you think it might be a problem that more people might face, you can raise it there, and then it's for everyone easily like retrievable.
Yeah, so it's still
research should also have, like it should give you some inspiration. There's a lot of research that has been done in that space before, and a lot of benchmarking has been done, and there are lots of creative solutions to be explored.
Yeah, and so we listed like some research and benchmarks that have been done on the subject. And so wait, I'll share the link of this here in the chat and I'll upload it on the website also.
I would generally say this is not a case, like a kind of the task where there's like, oh, this is the established like baseline, and you have to do X, Y, Z, and then on top you can build something. No. We know prompting is important. That's what we can tell you. Usually large models win by being large and potentially having lots of resources available at test time and at training time. But beyond that, there's been a few ideas, like generally how to like address reasoning problems, generally very difficult reasoning problems with smaller large language models. But this is not a task where there's like a super established benchmark that you have to start from to get anywhere. So it's really like the idea about RAG, you can do multiple passes, you could have multiple small models taking the problem apart, like it's really open.
Yeah, let's see if my submission got scored.
Yeah, so this can take a little bit because it's one.
Okay,
like, it's going to be queued. So yeah, good.
Yeah. So the process is that it gets queued and then it tries to load everything. And for example, if you try to pip install anything in your script, then it will fail and you will see status failed, as you can see here. And then if not, then you will see it's processing and then you'll get your score. So this is your public score, and then on the 26th of July, we'll release your private score. So right now you're only getting scored at like a part of like only on some questions, not all of the test set. And then you can see your score here on the leaderboard. And so you saw I was already on the leaderboard before, and I did another submission with the same model and same, like it's the same username. So you won't appear several times on the leaderboard. So make sure like you can make as many submissions as you want, and then you can select here up until 2 submissions that you want us to take a look at, and then these are the ones that will appear on the leaderboard. Yay, so it finished loading the model, and so now this is my system prompt, my parser, and this is exactly the same structure as you saw in my script. The only thing is that I added here a live text streamer, so you can see it reason live, which is, I think, very fun. So the first problem it encountered is a translation problem, and so we can see like what my model is thinking right now. So it understood it needs to translate two words, elms and angles, into Sylvan, and it looks at each one separately, and then it gives the final answers exactly as I asked in the system prompt, and then my parser parsed two answers. So I think I'm going on the right track. Now, second problem it's encountering is a fill blanks one. So again, it understood like the context, and then it says we need to identify the phonetic transcription provided. So it's taking a look at the context we gave it. So it's going to use it. So it's good. And so it solves every like sub problem into that problem, because as I explained, into a problem you can have several sub questions, and it needs to answer each one of those. And so it produced again in the format I asked and parsed 8 answers. Great, another type of problem. It needs to match the letters here. And you can see, like for now, it only encountered like the type of problems I listed in my system prompt. So maybe the indications I gave were useful and helpful. And if I didn't give them, maybe it wouldn't have known how to tackle each question. So don't hesitate to try. And the more linguini problems you test, the more problems you'll see, and you can flag like what's not going right with your problem and try to fix it. So I think this is much more visual than just uploading on the platform directly, because you get to see what's actually happening, and the problem is trying to solve are kind of hard. So yeah. Oh, good example. It gave final answer, but then it says, however, and then so it corrected itself, and then so it correcting for unique matches, and then it changed the final answer. So it's good, and this is something, for example, you have to take into account in your parser, because if my parser took this one instead of the final one, then it won't, like I won't score very well. It won't take the final answer, like the good ones. So make sure your parser is right, and that's something maybe I haven't thought about, and so then I can iterate and add it into my parser. Finally, another translation task. It analyzes the context. I find it fascinating looking at this. Yay, and it's done. And so what's cool with the collab is that you can check your script, like check for first of all what was parsed, and we can compare with the gold, and then you can even get a score for each item. So we can see it did not do too bad. It's not that far. Here, it just forgot an S, and then you can compare each one. Here you see that my parsed answer are not good. So this is an example of a mistake. For example, it gave the full like correspondence when it should have been just giving a letter. So even if here I got the C right, then the exact match is going to be 0 because it did not match it exactly, even if I was right. So I can include this in an instruction on how to answer the match letters type of problems. And then this is the score. So you can see the exact match is very low, but we got a not too bad CHRF. And this is just a score on 4 problems. And obviously you can do it on as many problems as you want. And then we added at the end a little section for you to experiment with the explanation track, with the human evaluation track, by adding the explanation column. So the explanation track wants a short structured explanation. If you see that like the thinking or reasoning trace of your model is not too long, and you want to feed that in, you can, but usually the reasoning traces or like the thinking process is very, very long. And so the human judges will not have time to read something that is like 1,000 of sentences. So you can try to summarize it. You can guide it through how you want it. For example, here I asked it to summarize the following reasoning into a few short bullet points, but it could be full sentences, it could be paragraphs, and it will feed it into an explanation column. And then you can see what the submission CSV would carry. So carry the idea. So now it's just 1, 2, 3, 4, because we have 4 linguini problems, but on the problems it would be the idea that given in the test set, and then my predictions, and then the explanation. And if this is filled to more than 50%, then you're eligible for the human track challenge, and your model will be created by a human jury. So I hope this is helpful. You can, like, this is your tool, so really feel free to add some cells if you want to, if like iterate on it, try as much as you can. And yeah, I think it gives you a good idea how it works for a submission. And yeah, you can ask any questions that you have. Maybe I can stop presenting my screen.
Thanks so much. I think it's really like this. It's like the path to submission is actually very short.
Yeah.
And you can just modify a little bit, load another model, submit it. There's a very low cost to submission. You have 8 per day. It's still 16 days. So, there's a
Oh,
lot of submissions that you could make at very little cost. Here's a question from Richard about the list of packages installed in the sandbox. Yes. I'll check what we can do. I think that might be helpful, especially.
Yeah, I have it in a doc file. I'll try to share it here on the chat, but otherwise we can just update it on the Hugging Face, like in the submission part, to tell you exactly what library you can use.
Any other questions or doubts?
Yeah,
the volume is pretty small. Again, you can look at the PDFs. It's usually 5 kind of languages, and then they have a varying number of subsets. Or one thing also maybe to consider, there are these, usually they start with like there's some context given, and they start with an easy question, and then they get harder. And depending on how hard they are, they get different amounts of points. So that is also, this is exactly the same setting as in the human evaluation. So every sub problem also has an amount of points that expresses the difficulty. So it's even harder to get a full set of points because it means you also have to solve the more difficult questions. You can't get away with just solving the easy ones. But maybe robustly solving the easy ones already gets you quite far. So this is kind of mimicking like human exams where like there's a broad base. It should be able to answer the first 3 questions, and then it gets into more detailed. Sometimes the difficult questions are more like free text as well, like translate a full sentence is much harder than just like mapping individual words to each other. So that's also part of the evaluation that is not currently part of Linguini. So there's a minor difference, but if you get the Linguini problems right, you will also get, there's a high chance you will get, if you robustly score highly on Linguini, that's a major achievement on its own, and chances are it might as well transfer to the new problems.
Yeah, and feel free to experiment with new models. Like, you have so many parameters you can play on. You can switch the model, play with the system prompt, play with the tokens, play with the techniques you want to use at inference. You can use a fine-tuned model. So really, you can be creative with this. And I think trying different techniques and seeing like how it goes gives you very good insights. And then you can use the score to, you can use the collab first, and then you can use the score to give you some guidance at which one you should go. And then you can like maybe combine 2 or 3 techniques you've tried to like make a final one.
If you want to, I can quickly share the version for TinyAya. So TinyAya is the model that we built in our lab. I just wanted to benchmark it because it's small. It's 3.35 billion parameters. Out of the box, I would not expect it to do well on this task because it wasn't optimized. It's not even a reasoning model. So, it's just a highly multilingual model. So maybe, it has some advantage due to that. But, that's just something that we added because we're curious for ourselves. So I took Rita's submission, I changed it in 2 places. So this is something you can do. You put the model that you copy, basically. This is a gated model. So this is also something that is important to take care of. We write this in the, it's also like explicitly, there's a warning in the instructions, submission instructions, that for gated models, you need to make sure that you follow their kind of guidance for publishing the weights because you're going to copy them in your space. Your space is to be public. So you're officially kind of re-releasing the weights. So you have to do this in a proper form. So if a model license doesn't allow that, or then you can't do it. if it might have constraints in terms of you have to publish under the same license, which is easy. Maybe you have to maintain the name. All the documentation has to come with it. So usually there's ways to do that, but take care. There's a reason why gated models are gated. So this is the case for the tiny IA model as well. I am compliant here with the requirements, but it is possible to use gated models. You just need to copy them first. And so I changed that. And then I played around a lot with like a kind of the system prompt. You could also put this in the user prompt. So that's another kind of, depending on your system, it might be more susceptible to whatever's in the system prompt, or more paying attention to what's in the user prompt. So that's also something you can vary. Where I added things is I was a bit more verbose in terms of kind of different task types, because what I noticed that small models often struggle with instruction following, and then we have the difficulty, depending on the task, you might have to output numbers or letters or phonetic transcriptions. So, and it always has to be a list matching the number of queries. So that's very important. If you mess that up and there's too many tokens, you will have a hard time parsing, and maybe your correct answer is in the text, but you can't get it out for the scoring. So this is really, really important for these small models. And so what I also wanted to do is like, okay, I'm doing chain of thought prompting right now. This model is not trained for reasoning, but I wanted to guide it a little bit to spend like a lot of time thinking about each problem in a way that I thought might be helpful. So first, kind of figure out what are the rules, the linguistic underlying rules. So I was thinking about how a human would approach this. I would probably first figure out, okay, what rules is this language based on? What kind of infer from the context, and how to apply them step by step to the new words, and that then think about, pay attention to the format that is required, then write a draft, then compare it again with the requirements, and then verify it's compliant with the rules, and then write it down. So I really wanted it to, you can't really force it to iterate because it's just a single pass, it's left to right generation. But I wanted to like put a lot of compute before committing to a final answer, because when I iterated with it, I saw a lot of times that the kind of right answer was there, or like almost good answer, but it was kind of like hidden in too much text, or it could have been fixed. Or it's also interesting, if you ran multiple samples from the same model, you can get a feeling for where the model is maybe uncertain about things. So you can also play with the sampling parameters. That's something I also did. So you can change the temperature, maybe nucleus sampling, something like that, because then you get a wider variety of answers. And special reasoning models usually require sampling, not really decoding. That also means if you submit the same kind of submission 5 times just by random resampling, you might get different scores. That also gives you a feeling for how much variance you get, like how robust your model is. And then something like the same examples that Rita had, you then see that I also told it, if there's no final answer keyword here, just try again, because I'm going to have a pain trying to extract these answers. So I just implemented a loop that just tries again, because it's a small model. I'm confident it will be able to tackle those problems even 5 times if necessary in the given time limit. So it just tries again, and then the second time around, it actually gets me this formatting. But you see here, I have like bold phrasing markup, which I don't necessarily want, because I can assume that the gold answers don't have bold phrase markup. Okay, well, actually, the final answers, when it verified the format here, it removed that. But in my parsing script, I could also adapt that to make sure that's kind of stripped off. But you can see here the rules that it kind of deduces, and when it's here, it's not too exciting. Here, this one is where it really struggles, like getting these phonetic transcriptions inserted, like figuring out what it actually has to do here, like filling that part of the blank and not like doing some kind of translation is something where it really struggles. So you can see this is not really the format it should be. And the larger model here had an advantage. So, there's like, depending on the task types, you might have some struggles here. And then, like we have this task again. And here you see it's not in a new line. There's also a number in there. So, like you might try again, or yeah, be careful with the parsing. So especially models that are smaller and are not like excellent at instruction following, especially when there's lots of instructions in a lot of different contexts, kind of doing repeated runs, really verifying your parsing script is really important. So it's one of the advantages of the task that we don't like give you the prompt that you have to use for your system, because we see prompting instruction also as part of the problem. And so the better your parsing script, also like the better this is all tuned together. So your model to the instructions and your parsing script to the way that the model follows your instructions, the better you have a chance at really maximizing the potential of the model that you choose to work with. Yeah, so there's more examples here. So again, like you can look at a lot of different examples. You can see what the variance looks like. And so you see my parsing script here, post-processing has just gotten very long because, I see an example where it doesn't work. I kind of add it. You can maybe also automate that way if you want. But since the parsing is just text, like string operations, it doesn't really, maybe you could also send this to an LLM in the second class, you can also do that. It doesn't really take much time, so it can be quite elaborate in your script. So yeah, that's all. And you can imagine that, to get to an explanation, you can either, for example, directly submit this one. Like I would say that's an interesting explanation, or you do a second pass, or you summarize this, or you ask the model to give you a summary of the explanation as well. So there's a lot of things to play with, but there is some potential to get small models to do at least parts of these. So you saw a 14B model and you saw a 3B model really prompt tuned. So there's quite a spectrum to work with, and it's going to be very interesting to analyze what kind of problems, what kind of models are struggling across the bench. So very curious to see what you all come up with and what everyone's hypotheses are, what works and what might not work.
Thank you, Julia. I thought like your example is very good. Like it shows how like a small model, even with the right system prompt, can like really perform better than even bigger models. So that's a motivation for you guys. Don't get discouraged by the fact that you cannot load huge models, because you can still do very good with small little ones. Like let's give them some appreciation. And there was a question about, is 14 billion the limit in your experience? What kind of quantization did you use with that? Yeah, so it was the limit with what we experimented, and it took some time to load. As you saw on the Google Colab, it's a T4 GPU, so it gives you an insight at how long it takes. And remember, the loading of your model counts in your 30 minutes limit, so you cannot go over that. And also there's the storage problem. But so for quantization, we used the library Auto AWQ. So I sent it in the list of libraries available. It's the one we use for quantized model. And you'll see on the Google Colab, actually the library we used is the GPTQ models one, which is more recent than the other one. But because the transformers on Hugging Face are a bit older, then Auto AWQ works better, and we didn't load the GPTQ model one. So I would advise you use, like you have plenty of models that are already quantized available. For example, the one I used was already on Hugging Face. So you can do that, and just make sure it works with the library available. And if it doesn't, then just like ping us and we can try to figure out how you can load your quantized model.
Has anyone tried submitting a system? Yeah, mixture of why not? You have to take into account you will still have to load the full model even if you don't use it at inference, all of it at inference time. So yeah, I can say it is quite interesting, yes, and it's a bit addictive as well because you're kind of like, it's really challenging. It's not easy. It's really not easy. It is kind of ambitious, but you can also become really creative, kind of figuring out how can you get the model to do something it wasn't trained for. It doesn't necessarily have the knowledge, but you still believe there's something in there, right, that should enable it to.
Yeah. And I'd be really excited to see how, so you can totally use a mixture of experts. And even we were thinking about like how we could experiment with that. But just since you're like using several like models and like experts, just make sure that like you load all the weights in the repo. So it's not only the active weights that we use, just make sure everything fits in the repo again. And it doesn't exceed the limit. But apart from that, yeah, you can definitely experiment with that. I think it would be really fun. The challenge itself is very interesting. I think I'll spend this weekend and make a few submissions. Yay! Thank you for this session. Thank you for your interest. And really don't hesitate to ping us for anything if you need help on submissions. And we'll update the website very soon so you can have more insights on why your submission fails if it does. And yeah, you can also use the list of library I just added to the chat to answer to one of the questions, and I'll update it on the Google Doc that you all have access to, so you have enough resources. And really experiment on the Google Colab. I think it will help you outperform our baselines.
Yeah, thank you everyone for coming here, being curious and interested, and I'm really looking forward how we address this challenge together. Like that's the whole point. Like we want to learn together. Yeah, thanks so much, Rita. Rita prepared all of these excellent documentation to make it more accessible. So really in a very short time. So thank you so much. I think this was really.
Of course, it's my pleasure. I'd love to see growing excitement on the challenge, and really we want to make it as easy for you to participate. Like this is to show you that the bar to participate is not that high. You don't have to create a model. You can use any model that you want, and it's for you to have fun too. So don't hesitate. Like at one submission is still good. Like. Yeah, I added the link to the doc again, but I'll add it to the Hugging Face platform and website, so you'll always have access, like you don't lose the link.
Well, thanks everyone. Have a nice weekend experimenting. Now you know what to do. If your team left the World Cup soccer already, you might as well spend the time. No, I'm kidding. Looking forward. And thanks all for your attention and time and curiosity and interest. We'll see you. And we'll see your submissions.
Submissions. Bye.